have seen diffusion and osmosis. Today in this video, we will see what are the types of osmosis and active transport. So before starting with the video, we have already discussed about osmosis and diffusion and its definition and different types of solution, that is isotonic, hypotonic, hypertonic types of solution. So today we will discuss about types of osmosis. Osmosis is two types. First is endoosmosis and second is exoosmosis. So osmosis is of two types. One is known as endoosmosis, another one is known as exo with endoosmosis. It takes place when solvent move from outside to inside the cell. So endoosmosis occurs when solvent is moving inside the cell. That means water flows from outside to inside the cell by this process. We can take an example. Again, here we have taken beaker, and in this beaker we have taken an animal cell and we have taken solution. So this is the solution. So in endoosmosis what will happen? Water will move from outside to inside of the cell, and this process is called as endoosmosis. And when water moves inside the cell, for example RBC's cell, when placed in water they burst. In plant cell, due to the presence of rigid cell wall, such a disruption is prevented. Now let us take another type of osmosis, that is exoosmosis. Exoosmosis. It is the movement of solvent. From inside to outside of cell. Now in endoosmosis we have seen that water is moving inside the cell from outside and cell gets burst. It gets swollen up and then it gets burst. In exoosmosis, the solvent will come out of the cell. Let us take an example of erythrocyte, that is RBC, animal cell. We have taken a beaker. In this beaker we have taken an animal cell. We have taken a solution. Let us take an example of 2% sodium chloride solution. When RBC is kept inside a 2% sodium chloride solution, what will happen? Water from inside the cell, it will come out of the cell. Since this 2% NaCl solution is a hypertonic solution, and we know what happens for RBC, and we know what happens in hypertonic solution. Water comes out from the cell. In the same way over here also, water is coming out from the cell, leaving its cytoplasm, and cell gets shrink, and this process is called as exoosmosis. phenomena of exoosmosis can also be seen in plant cell, where it is placed in a hypertonic solution. Water from the cell sap flows out due to exoosmosis through plasma membrane, due to which we can see shrinkage in protoplasm. The protoplasm along with the plasma membrane will separate from cell wall and will move away, assuming some spherical or irregular shape. This phenomena inside the plant cell is called as plasmolysis, and the cell in this condition is called as plasmolyzed cell. Let us see through an example. As I said, this phenomena can be also seen in plant cell. So let us take a plant cell. Inside a beaker, a plant cell consists of cell wall. This is the cell wall. Inside cell wall there is plasma membrane. So this is plasma membrane. This is nucleus, and inside this plasma membrane there is cytoplasm. And we have taken a solution. That solution is a hypertonic solution. So what will happen? Since we know the nature of hypertonic solution, water from the cell will come out in hypertonic solution. So water will come out, since the content, most of the content of cytoplasm is water. So from cytoplasm the water will come out. So this is the first beaker. Let us see what will happen after that. So when water will come out from the cell outside, that is outside the cell, during that time there will be shrinkage in the cytoplasm and plasma membrane. So they get shrink. This phenomena becomes spherical or irregular shape. So this phenomena is called as plasmolysis. And this cell in which the plasma membrane and this protoplasm gets shrink is called as plasmolyzed cell. So this is what cell? This is a plasmolyzed cell. Now let us see the next topic, that is active transport.